Okay, so we're looking at, in our next video here, we're still in section 11.4. We're going to be looking now at word problem number 6 in the book that you would have copied down. If you didn't, here it is. And again, please look in your textbook that's located online on your resources. And if you don't know what that textbook is, please flag me down in class or flag down a classmate. I'm sure someone will be able to help you. But here is the question. A turbojet flies 50 miles per hour faster than a superprop plane. If a turbojet goes 2,000 miles in 3 hours less time than it takes the superprop to go 2,800 miles, find the speed of each plane. So let's go ahead and do a dirt chart here. So here's going to be the turbo plane, and here's going to be the superprop plane. We'll just call that SP. Now it says in the question here that for question 6 that a turbojet goes 2,000 miles in 3 hours less time than it takes a superprop to go 2,800 miles. So this takes 3 miles less than the superprop plane to go 2,800 miles. Doesn't specify a time, but we know this one takes 3 hours less than this. Okay, my time goes here, my time goes meow. Okay, let's see if we can talk about the rate here. What does it say in the earlier part of the problem? It says that a turbojet flies 50 miles per hour faster, so this is going to be R plus 50. If this is R, then this is going to be R plus 50 because this is 50 miles an hour faster and it goes in 3 hours less time. So this is going to be 2,800 equals R times T. This is going to be 2,000 equals R plus 50 times T minus 3. So again here, we're going to go ahead and solve for R. So we're going to solve for R equals D divided by T. And it's going to work out like this. So we're going to label this number 1. We're going to label this number 2, this one down here. So we're going to have R equal 2,800 over T. For the second one, we're going to have R plus 50 equaling 2,000 divided by T minus 3. So I think the numbers in this one are going to be a little big, but let's see what we get. So I need to get R by itself, so I'm going to subtract 50 from both sides. And that's going to give me R equals 2,000 over T minus 3 minus 50. I'm going to leave it at that. Now that we have the two equations written for each other, I'm going to go ahead and set them equal. So I'm going to have 2,800 over T equals 2,000 over T minus 3 minus 50. And as I get that, I need to determine what am I going to distribute and multiply everything by. So I have a C, I have T and T minus 3 in the denominator. So I'm going to go ahead and multiply by the quantity of T and then T minus 3. Again, up on top here, in the case when I multiply 50, nothing's going to reduce. So T times T will be T squared. T times negative 3 will be negative 3T. So we're only going to use this one for the negative 50. Let's see what happens as we distribute. When I multiply this by 2,800 over T, we see the T's reduce, giving us 2,800 times T minus 3. In the next part of the problem, we see that we have a T minus 3 here, and we have T minus 3 here. Those are going to reduce, giving us 2,000 times T. In the last part of the problem here, we see we have a negative 50, and nothing's going to reduce. So we're going to multiply it by just this product here. So it's going to be minus 50 times T squared minus 3T. So we're going to distribute, and then we're going to combine like terms to see what quadratic equation results. And we should get something quadratic. It looks like it's going to be here. So we have 2,800 being distributed through T minus 3, and negative 50 being distributed through T squared minus 3T. So this is going to be 2,800 times T, which is 2,800 T, 2,800 minus 3, which is minus 8,400, equals 2,000 t. Now, minus 50 times t squared will be negative 50 t squared. Negative 50 times negative 3t, and I distribute that here. That's going to be positive 150 t. From this point, I see what I can combine. So if I look to the right-hand side, it looks like I can combine this. I can combine this, and that's going to give me negative 50 t squared plus 2150 t. And that's still going to equal what's over here, 2,800 t minus 8,400. Now what I'm going to do is I'm going to go ahead, I'm going to try to get this to the other side, because this is a negative 50t squared. I want this to be positive 50t squared, or whatever else it comes out to be. But there's nothing else to combine it with here, so I'm just going to go ahead and add 50t squared over here. And then I'm going to subtract 2150t from both sides. I'm going to put the result of this on top. I know this is going to be 0. That's going to be 50. Let me just show this work here. 50t squared. 2,800 minus 2,150 is going to be plus 650. And then minus plus 650t minus 8,400 is going to equal 0. So right now, what can I factor out of this? We can reduce this significantly by factoring out 50. So this is going to be 50 times t squared plus 13t minus 168, and that'll equal 0. And if I divide by 50, we get t squared plus 13t minus 168 equals 0. So now I have a significantly simpler problem. But I still need to factor this or use the quadratic formula. So I'm not quite sure what these numbers are actually myself. I have a few ideas, but let's just go ahead and see if we can come up with a systematic way of coming up with these factors. So because this is a negative product, I need two numbers that multiply the 168, but they have to have, because this is a negative product, they have to have a difference of positive 13. So right now I just want two numbers that multiply to this, but a difference of 13. So 1 times 168, that has a difference of 167. 2 times 84, that's a difference of 82. That's still pretty big. Well, 3 will divide this evenly. That's going to be 3 times 56. I know that because 1 plus 6 is 7, 7 plus 8 is 15. If I add these digits together individually and I get a number that's divisible by 3, I also know it's going to be divisible by 3. So let's see. What about 4? 4 will divide that, and that's going to be 4 times 42. That has a difference of 38, so nothing yet. 5 doesn't divide it. I do know because it's even and it's divisible by 3, I know it's going to be divisible by 6. And that's going to be 6 times 28. That has a difference of 22. So we're getting closer. We're getting closer. What about, let's see, 7. 7 might be it. Because 7 times 20 is 140. So 7 times 20 is 140. And then go 28 more, so that's going to be 7 and 24. 27 minus, or 24 minus 7, and it's still 17, so that doesn't help me. Let's try 8. What's it going to be? 8 times 21. Well, 8 times 21, yes, 21 minus 8, in fact, is 13. And we want this to be a difference of positive 13. So that means since it's going to be positive, we're going to have t plus 21, and then we're going to have t minus 8 is going to equal 0. So there are a pair of factors that give us a product of negative 168, but give us a difference of positive 13. And to go ahead and set each of these equal to 0. Now some of you may see that this is going to clearly be negative. Still show me that result. I know that this is not going to work because we can't use negative time. But you need to show that solution and show that you reject it. and understandably so. So now we have t is equal to 8. So we have this going 8 hours. Well, if this is t minus 3, that's going to go 5 hours. So we need to see if this makes sense now. So what we're going to do is we're going to take 2,800, we're going to divide that by 8 and see what we get for an answer here. So actually, you know what? Let's go ahead and figure this one out first. 2,000 divided by 5, that's going to get us an answer, if I'm not mistaken, of 400. So that'd be 400, because 400 times 5 is 2,000. If this one is 50 bigger than this, then this should be about 350. And 8 times 350, yeah, that's going to work out to be 2,800. So our answers do, in fact, work out for this one. So we've got the correct solution for this. So just to reiterate this in case you could not see that before, in case it was out of eye shot, I have t equals 8, which I put into here. T minus 3 would equal 5. Since I know 2,000 divided by 5 is equal to 400, I know the speed is 50 miles an hour faster than this. If this is 400, this must be 350. And let's see, 350 times 8 does in fact equal 2,800. So I know I have the correct information for this problem. So this is the correct solution. You'll notice the equation here, a lot simpler than the one we may have generated in the first class. Let's go ahead now to do question 8 and tackle the last of the word problems. So let me go ahead and read question 8. You will find it in the textbook, though, and I encourage you to please look at that and put that into your notes as you're doing this problem. On a sales trip, Jay drives the 600 miles to Richmond, averaging a certain speed. The return trip is made at an average speed that is 10 miles per hour slower. Total time for the round trip is 22 hours. Find Jay's average speed on each part of the trip. So we're going to go ahead and make our dirt chart one more time. D, R, T. So this is to Richmond. We'll label that number 1. And this is the return trip. Assuming that is going back to the original place, I think it's safe to say that the trip in each way is 600 miles. They don't say anything general about that it goes a certain rate in a certain time. They do say a couple things, though, on the way back. They say he goes 10 miles per hour slower than this. So hopefully most people are comfortable by now to say that if this is 10 miles slower, this will be r minus 10. The other thing it says is that the total time for the round trip is 22 hours. So if this trip were 10, this would be 22 minus 10, which would be 12. If this trip were 20, this trip would be 22 minus 20, or 2. So this is going to be 22 minus t. This is much like the problem we did in question number 2. So that's how we put together our dirt table for this problem. Next, again, we're going to solve for r. We're going to use the formula r equals d over t. So, and we're going to label this 1 and 2. So for number 1, we have r equals 600 over t. And then for number 2, we have r minus 10 equals 600 over 22 minus t. If I add 10 to both sides, that's going to give me r is equal to 600 over 22 minus t plus 10. So now I have r for both parts here. I'm going to set these two equal to each other, just like I have in the previous questions. So I'm going to have 600 over t equals 600 over 22 minus t plus 10. So what I'm going to go ahead and do now is I'm going to multiply through by the two denominators, t and then 22 minus t. So for this one, I'm going to box up here the product of this. This will be t times 22 is 22t. Then t times negative 2 will be negative t squared. And I'm going to be using that one time here. The t's reduce, leaving me at first with 600 times 22 minus t equals, here the 22 minus t is reduced, giving us 600 times t. And then here, nothing reduces. So I'm going to take the whole thing, which is going to be plus 10 times 22t minus t squared. Next, I'm going to go ahead, I'm going to distribute through here. I'm going to distribute positive 10 through here. And let's see what we get. 600 times 22, that's going to be 13,200 minus 600t equals 600t. Now, plus 10 times 22 will be plus 220t minus 10t squared. Positive 10 times positive 22t is plus 220t, but positive 10 times negative t squared will be negative 10t squared. One more thing. I showed you a trick in problem 4 about reducing things that are identical. This only works if the signs are the same. This is a positive 600t. This is a negative 600t. We cannot simply cancel this on both sides. So we're going to go ahead and combine like terms for this. So we're going to get 13,200 minus 600t. This is going to equal 820t minus 10t squared. And just like we've gotten in other parts of the problem before, I want this t squared term to be positive, so I'm going to add it to the other side. So I'm going to add 10t squared. I'm going to subtract 820t from both sides. So this is going to reduce to 0. I'm going to put the 10t squared here. I'm going to move this up a little bit. I'm going to move, like here I've got negative 600t, negative 820t. I'm going to move that here, just so it's in descending order. So that'll be negative 1420t, and then I'm going to put this plus 13,200 here, and that's going to be equal to 0. So no good numbers in this problem. The numbers are just big. Let me move this problem up to here and make sure I can show everything still on this. Okay, very good. So I'm putting this original problem up here. So 10, or not original problem, but the quadratic equation we came up with. 1420t plus 13,200 equals 0. So one thing about it, please feel free to use a calculator. And 2, I won't give numbers this big on your test. I'm going to factor out a 10. That's the best I can do. So this would be t squared minus 142t plus 1320, and that's going to equal 0. So when I divide both sides by 10, that'll be t squared minus 142t plus 1320 equals 0. So we're looking for two numbers that multiply to 1320. Now the first ones that seem to jump to my mind are 132 times 10. Now I know that 10 is going to divide this, and just as it turns out, 132 plus 10 is also 142. So it looks like these numbers are going to work just perfect for the work that we're going to do here. So this is going to be t minus 132 and t minus 10. It'll equal 0. So when we solve for this, we need to set t minus 132 equal to 0, and then t minus 10 equal to 0. Well, if I add 132 to both sides, t will equal 132. Here, if I add 10 to both sides, t will equal 10. So when you get to this part of the problem, you need to think about what's going to make sense. So, because if you have 22 minus t, 22 minus 132 is not going to make a whole lot of sense. So that number is probably going to be a little high. But 10 hours seems to make sense. So let's just go ahead and put 10 in here. And we're just going to kind of see 12. So we have 10 for this trip and then 12 for the return trip. 22 minus 10 is 12. Well, let's see. If it takes 10 hours to go here, then 600 divided by 10 is going to be 60. Well, if he goes 10 miles an hour less, that means he's going to go 50 miles per hour. And 50 times 12 is also equal to 600. So it looks like that our solution to this checks out. but let's make sure that we answer the question. We want to find his average speed on each part of the trip. So for R1, that'd be the R1 here, and this would be R2. His average speed is 60, and I believe according to this question is miles per hour, but let's make sure that we have that right. Yep, it's miles per hour. And then his rate on the return trip home is going to be 50 miles per hour. So make sure that you are showing what they are asking for when you're answering the question. Hopefully now that you've had a chance to work out some of these in class, and hopefully that you've had a chance to watch some of these videos, this will provide a clear idea of what the expectation is when working on these challenging problems. Please see me in class if you have any questions. Thank you.